Welcome back. In this video, we're going to try to find the domain of definition for the following function, g of x given by the square root of ln of x plus 1 over ln of x minus 1. We have here not only one condition, but 2 or 3 conditions at least. So this one will be a great check for our understanding. Okay? So the first thing that we can do is we see that we are inside a square root. So we need to have ln of x plus 1 over ln of x minus 1 greater or equal than 0. So we need to have that condition. The second condition is that we don't want to divide by 0. So that means we need to have this one different from 0. So we need to have ln of x minus 1 different from 0. Another thing is that the natural log should be defined. So that means x has to be bigger than 0. Okay? This condition, the first one, is easy. This one here, the natural log of x minus 1 different from 0, that means is x different from e. We know that from the graph. If you graph the natural log, if you remember, so the natural log of 1 is 0, but when this is 2, this is e. So when we have the natural log of e, we have 1. So we want to be different from 1. So we want x to be different from e to be different from 1. Okay, because this is 1. Okay, so we have these conditions. Under these conditions, so we need to have x different from e, and also x bigger than 0, and also this condition here. So this one we need a table. So let's do a table for that. Okay, and we're gonna see that we can get the result that we need really quickly. So our x is gonna be between 0 plus infinity, with one condition is that x can't be equal to e. We have 2 lines for that. So this is to remind us that x can't be equal to e, and the 0 is excluded as well. So here we have x plus 1, ln of x plus 1, ln of x plus 1. When can this one be 0? Okay, so ln of x is minus 1 when x is 1 over e. So it's here. So this is 1 over e. Ln of x minus 1 equals 0 when x is e. Okay, and here we're going to have the sign of ln of x plus 1 over ln of x minus 1. Okay, so here when x is bigger than 1 over e, so this quantity is positive. Okay. When x is e, this quantity is 0, and we avoid that. When x is less than e, I'm sorry, and here it's negative. When x is less than 1 over e, ln of x plus 1 is negative. When x is equal to e, this quantity, the second one here, the second row, is 0. So because we have problem when x is e, we avoid that. So here, when x is less than e, this quantity is negative. When x is bigger than e, this quantity is positive. To get the sign where this one is positive, we just multiply. Plus times plus is plus. Plus times minus is minus. Minus times minus is a plus. So here we can read from the table. So the 0 is excluded, and we go up to 1 over e. We don't have a problem with 1 over e, so we include it. And after that, we go to 1 over to e, and e is excluded. So we take it out, and we go to plus infinity. So this is the domain for our function. Okay. Okay, we have all the conditions that we need. So we are working on this domain because of this. We have this condition because of this. Okay, and we have this sign because of these restrictions on these two. So that's why we have this domain. Finally, this is our domain for this function. Okay, you can graph the function and see what your function is defined. The t with t I 84, we don't need the square root because the square root gets more values and more computational effort to the calculator. We can just do, you can define a new function, call it f of x, okay, given by ln of x plus 1 over ln of x minus 1 with this condition, x is bigger than 0. Okay, it's the same. Okay, and the calculator is gonna do the same thing. You might see a part when you graph the function. You may see a negative part, but don't worry about that. Don't worry about this, because we said this one has to be positive. We should see it in here, so it's not defined here. So don't worry about negative parts when you graph without when you graph it without the square root, but just to see what this one, the domain of definition.